So we have seen that another way to regularize our network and to make it generalize better is through data augmentation. So data augmentation, we presented it with images in which we had the picture of a lion and then the same picture of the same lion, but in different poses, orientations, transformations, so that the output had to be the same. If we think of our neural network as a function relating y is f of x and the function is defined by the weights, we can think of data augmentation as a way to fill the domain of the domain of our function. So this x, we have a set of training pairs. So what is the location in space of those x? So maybe like this, maybe like this, like this, like this. So don't take into account these labels here. It is just to illustrate the idea that these x points can be distributed very differently in space. And you can imagine that learning a function in this context is much simpler than learning a function in this context, because there are big gaps in which you don't know how the function behaves. So data augmentation is a way to make the weights to be more aware of what is the shape of that function. So with images, it is very easily seen. So we have some image and then we can transform it, and we can transform it by geometrical transformations, or we can blur it, or we can change the intensities, or we can add noise, or we can make it gray, we can crop it. So all these versions, they should have the same label. So what we are doing is just from given one point, we are constructing 10 other points that are somewhere in this space, so that the network can learn better how the function relationship between x and y is. So this is with images. What about words? So when you have words, you can substitute some words by synonyms, or let's say that you have a text. You have to decide whether it is a positive or a negative comment on something, and then another possibility to have more text is back translation. So you have the text in English, you translate to Spanish, and then from Spanish you translate it back to English. So probably the original text and the back translated text will not be the same, exactly the same. So now you have two versions of the same comment, but now, so it would be the equivalent of making these kind of changes. Okay, so you can also randomly insert or delete words from the sentence, as long as these words are the deleted words are not critical. Probably the text will not change its meaning. You can shuffle the text, so you can reorder uh, the 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 words in the sentence, as long as it keeps the meaning. Or you can replace some words with semantically similar words. It is not exactly a synonym, but somehow a related word. So, for instance, let's say that I saw my father in the morning, or I saw my mother in the morning. So it is not the same word, but it is an augmented version of the original text. You can also do contextual augmentation. So you can use language models to predict what are what. So you remove one word, so you make this bird, for instance, to predict what is the word that we have removed. and so you have a different version of that word. Or you can split the sentences or merge sentences into larger ones. So you can see there are many operations that you can do on words, so that you can do a kind of data augmentation as we did in images. And in your context, you can also have some other data augmentation tools. Something that is now somehow related to this data augmentation is the data augmentation at the level of generation. So you don't retrain the model anymore, but the output, you want it to be augmented somehow. And so let's say that you ask a question about a specific protein to an LLM, so to a language model, and then instead of just letting it answer, what you do is you look for relevant information about that protein, and then you retrieve the important statements or the relevant documents or whatever, and you accompany your question with the documents that you have retrieved. This is called retrieval augmented, because the generation, and augmented because our question has been augmented through this retrieval of relevant documents. And then the language model somehow has to answer this question given these extra documents and all the knowledge it has. So this is now very popular, this approach, this retrieval augmented generation. It solves some limitations. So for instance, LLMs have learned on outdated data, or they may provide incomplete responses, and with this RAG, with this retrieval augmented generation, you are complementing whatever the language model knows with extra information. There are some challenges in it. So for instance, what if during the retrieval we retrieve incomplete or incorrect information? It will not be used. So incomplete information will not be used in the generation, or incorrect information will bias the generation or the generation. So even with all this information that we have provided, even if it is correct, the language model may give unexpected responses. And there are some advanced techniques to it, and so somehow optimizing the knowledge base and the kind of questions that the user can make, so that we can improve the retrieval. Also, we can retrieve in multiple ways and combine somehow the output of this retrieval, try to evaluate what is the quality of the different retrievals, only use the documents with the largest quality, and also some post-retrieval. So once we have retrieved the data and produce an output, somehow trying to measure what is the coherence and the factual correctness of the answer. So now that there is a lot of research in this area. Another way to try to borrow X points is by training on some other domain that is somehow related. Okay, so for instance, it is something very common to do something called transfer learning. So let's say that we are interested, our problem is classifying a set of images, but we don't have those many. So let's say that we have just a few thousand, and these few thousand we have to classify into 5 labels. And if we want to train a large neural network, we don't have enough data to train these many parameters. But then what we can do is transfer learning. So transfer learning is you take this big network and you train it on a huge database. So for instance, ImageNet, I think it has a few millions of images with different labels, like what kind of object you can see in it. And then it has been shown that the first layers, especially the convolutional layers, they are more related to visual information understanding. So it is just extracting features that are useful to understand images. So you train this network for understanding these images and assign the kind of object, but you think that the first layers are mostly related to extracting visual features, and the last layers are more related to translating those visual features into useful labels. And then what you do is you take these layers, you freeze them, so you will no longer train them, and just train a few small layers that will translate these visual features into the labels that you need. And also here, some image processing can be very useful to help this translation, and also even to do some data augmentation. So with this, we would finish this part of data augmentation, and see you in the next one.